What's up? Today we're talking about a cool concept in math known as the constant of proportionality. And you might be saying to yourself, oh my gosh, why are there all these sophisticated fancy terms in math when sometimes they're just describing something that's not that complicated? And I don't know, we just have these fancy terms. And I think this is a case where we do have this long term and it's actually describing something that is not very complicated. And let's get right to it. So, we know a little bit about proportional relationships. We know that proportional relationships are relationships between values, whereas one value or amount or quantity changes, the other one changes at the same rate. So if I buy 3 Pokemon cards for $1, then I'm going to buy 6 Pokemon cards for $2. And here I am dividing by 3 or multiplying by 1/3 to get my value there. And because the numbers change at the same rate, these are proportional relationships. And we can also see proportional relationships in ratio tables like this one. And you'll notice there is an X and there's a Y, and we'll talk about what those represent in a moment. But let's first look at this ratio table and look at how to find the constant of proportionality. Well, when I look at the relationship between the numbers, I notice in each row I am multiplying by 3. I'm multiplying by 3. So I should actually show from X to Y, I am multiplying by 3. And when you think of the word constant, you can kind of think of it as something that is unchanging. So when you look at this ratio table, you see all these different numbers, but the thing that's not changing, the thing that's a constant, is the number 3. And that is because that is the constant of proportionality, that number 3. It is basically the multiplier, the amount that you multiply X by to get Y. And this concept is useful in so many different ways because let's say we have a really, really large amount here and we don't know what the value of Y is, then we're able to find it because we know the constant of proportionality. Now, let's try this with a real life example. So I have a bunch of kids that really like trading cards, baseball trading cards. And so let's pretend that X represents baseball trading cards, which I'll make TC. I'll call them TC. And Y represents the price, how much they cost. That's not a very good dollar sign, is it? Maybe I should just write price. Okay, there we go. Let's pretend you can get 3 baseball trading cards for $12. Now, I got to be honest with you. I don't buy baseball trading cards, so I don't know if this is a good deal or a terrible deal. Anyway, I see that in each row I am multiplying by 4, which means, I'm going to put multiply by 4 there, the constant of proportionality is 4. And when I know this number, it tells me that hypothetically, let's pretend I have 10 trading cards, then I multiply that number by 4 to get the price, which is 40. Anyway, now it turns out that ratio tables are very useful for finding the constant of proportionality, but we also have a formula. Isn't that great? K represents the constant of proportionality. The Y represents this number here, and we'll talk about what that means. And the X represents the numbers in this row, and we'll talk about what that means. Now, you'll see I did X and I did Y. In math and in science and in this world, X represents something called the independent variable. And I'll give you a brief explanation. We are not going to get too deep into this, but it is something that students of math will be working on for a very long time. And so it is important to know the difference between x and y. Y represents something called the dependent variable. And you might be saying to yourself, oh my goodness, more confusing math terms. Here's the way to think about it. The best way that I can think about it is one number or one value depends on the other. One thing depends on the other thing. And so when you're trying to figure out what's x and what's y, you can look, let's just say it like this ratio table. Do trading cards depend on the price, or does the price of the trading cards depend on the number of trading cards? Well, it's always the case that y depends on x, which is why it is the dependent variable. And you see the word dependent there. And that makes sense because the price of the trading cards is going to depend on how many trading cards I buy. And so the number of trading cards I buy is the independent variable. It kind of stands alone. It doesn't depend on anything else. Again, don't worry, at least if you're in my math group, don't worry if these are a little confusing or hard to grasp at first, because we will be working more on it. And at least in my math group, we are going to give you the x and the y for now, so you won't have to figure out which one is which. Now back to this handy dandy formula. We've got 3 values, and what this means is that if I have any 2 values, I can find out the third value. If I know k and y, I can find out x. If I know k and x, I can find out y. And if I know y and x, I can find out k. So that is really cool because we don't always have ratio tables like this at our disposal. So back to our original ratio table here, or not the original, but the one that we were just talking about with trading cards, baseball trading cards and prices. So we know that I can buy, 3 baseball trading cards for $12. Let's say that's all I know. Well, one way to find out the constant of proportionality is to just plug it into this equation. Let's do it. K, which represents the constant of proportionality, equals y, that's 12, and mind you, it's over there, 12 over x, which is 3. And again, we see the x is over here. And what is 12 over 3? Well, it's 4. So k equals 4. And now that we know what k is, that means I can take any number and find out the other value for it. So, I mean, that was a little confusing. Let me give you an example. Let's pretend I'm at the same store with these baseball trading cards, and I want to buy 10. I want to buy 10 baseball trading cards. Well, remember, the trading cards are the x value. So I know that k is 4, but I don't know what the price is, and that's why. And I'm buying, what did I say? 10. Well, because I know 4 and I know 10, I can find y. And we can multiply both sides by 10. Now we cancel out 10. And we get 40 equals y. So the price of 10 cards will be $40. Now what's even cooler is we can actually graph on a coordinate plane. We can actually graph these values. And you might be wondering, well, why in the world do I even need to do that? And the truth is that sometimes it can be helpful to have a graph, because let's say you own a big warehouse that has lots of cans of tomatoes in it. I don't know where I came up with that. Oh my gosh, that was a terrible. These lines are going to represent different proportional relationships that can tell you valuable information about how many cans of tomatoes you can sell for what price. I don't want to lose you here. So let's go back to talking about the constant of proportionality, this value k. So you can take proportional relationships. So here I have a coordinate plane, and I count 1, 2, I count 1, and then I go up 3, 1, 2, 3, and I've gotten to this point here, which is 1, 3. And because I see that this is a proportional relationship, proportional relationships go through the origin at 0, 0. I won't go too deep into why that's the case, but you can actually see. So remember, in coordinate planes, whenever we plot x, y, it always goes in this order. It's never y, x. That's wrong. It's always x, y. So I've got x equals 1. So we know that k equals y over x. And if x is 1, y is 3. So my k is 3. And you can even look at another plot, another point on the plot, and see if that, if that holds. And then here, what would be my constant of proportionality in number 2? This is from a worksheet I gave to my students. Well, we have x and y here, 4, 1, and I'll put x and y so you know. And k equals y over x. K equals 1 over 4. So it's 1/4. And here, k is going to equal y over x. And people mix these up a lot. They always want to do 3 over 4, and that's wrong. You just got to remember, and if it helps you to just always write y over x, do that, and then you can remember it's 4/3. And I'll stop there for today. That's a lot of information. And if there's one takeaway that I want you to have, it's really just that this formula exists and it can be very useful. And when you're trying to find the constant of proportionality, you can apply this formula, and it will give you some helpful, valuable information. And that's all for today.